The Andromeda Galaxy has played a major role in reshaping our understanding of the universe, challenging the idea that the Earth is the center of the universe. A stream of water shows that the Milky Way, our home galaxy, is just one of many scattered across the vastness of space. Advances in observational technology, especially the deployment of instruments such as the James Webb Space Telescope, have allowed us to look deeper into the universe and unravel the mysteries of Andromeda. Believe in this nearby galaxy. More than a century ago, the main site of the Milky Way was a band of scattered moons stretching across the night sky. This idea, influenced by the limited technological capabilities of the time, prevented astronomers from seeing individual stars in our galaxy. But there are still different ideas, often comparing the Milky Way to the center of creation, where the worlds in heaven and on Earth meet. It wasn't until the 17th century that our knowledge of the Milky Way was changed by Galileo Galilei and his pioneering work with the telescope. Galileo's observations showed that Milky Way is not only a group of moons, but also a large collection of stars, planets, and celestial bodies scattered in space. Based on Galileo's insights, Thomas Wright proposed a groundbreaking hypothesis in the 19th century, suggesting that the Milky Way is not a random scattering of stars, but a flat disk with a bound solar system. By him, however, Edwin Hubble's discoveries in the early 1900s completely changed our view of the universe. Using the 100-inch Hooker telescope at Mount Wilson Observatory, Hubble discovered distant nebulae beyond the Milky Way and found them to be galaxies themselves, each containing billions of stars. Among these galaxies, the Andromeda Galaxy, or M31, is one of the closest galaxies to us. The history of observing Andromeda goes back centuries, with records of its existence dating back to the 10th century, when Iranian astronomer Abd al-Rahman al-Sufi described it as Little Cloud. Despite the lack of telephonic equipment, Sufi's keen powers of observation enabled him to identify Andromeda as a celestial entity separate from the familiar stars of the night sky. Detailed observations of Andromeda began in 1612, when Simon Marius provided a comprehensive description based on telescopic observations. Later, in 1764, Charles Messier named Andromeda as M31, because the discovery was only Marius and ignored al-Sufi's earlier sign. In 1864, when English astronomer William Huggins made deep observations and clarified the nature of this mysterious galaxy, great steps were taken to understand Andromeda. Each successive astronomer contributed to the growing knowledge about Andromeda, which led to a better understanding of its structure, composition, and location on the planet. William Huggins' first observations of the Andromeda Galaxy marked a turning point in our understanding of this galaxy. Realizing that its signature was different from the gas nebula, Huggins paved the way for a deeper exploration of Andromeda's true nature. Andromeda, despite its massive size, is estimated to have a mass between 1 and 2 trillion times the mass of the Sun. This massive planetary structure, so close to us in space, has fascinated scientists for centuries. At around 10 billion years old, Andromeda is considered an ancient planet, suggesting that it has a rich history of formation and evolution. One of the most interesting aspects of Andromeda's formation is that it is thought to have resulted from the merger of several smaller original galaxies over billions of years. This process, driven by gravity, led to the formation of the beautiful Andromeda Galaxy that we see today. Galactic mergers are common cosmic events that play an important role in shaping the growth and formation of galaxies on timescales. For a long time, astronomers believed that Andromeda was larger than our Milky Way. This misconception is partly due to the fact that Andromeda, as seen from Earth, is very large. However, recent research has led to a reevaluation of these beliefs, and scientists have revised their estimates of Andromeda's mass. Current understanding suggests that the masses of Andromeda and the Milky Way are much closer than previously thought, indicating the difficulty of accurately measuring the masses of galaxies. Andromeda is 220,000 light-years larger than the Milky Way. Its large size makes it a large planetary entity occupying a large area. One of Andromeda's most notable features is its supermassive core, a highly energetic region at the center of the galaxy powered by a supermassive black hole. Observations with advanced telescopes, like the Hubble Space Telescope, have revealed intriguing phenomena within Andromeda's nucleus, including 2 points of concentration where emissions are more intense than in surrounding areas. These observations shed light on the dynamic processes occurring at the heart of Andromeda and deepen our understanding of galactic nuclei. The supermassive black hole at the heart of the Andromeda Galaxy commands immense gravitational influence, with its mass estimated to range from 1.1 to 2.3 multiplied by 10 to the power of 8 solar masses, or approximately 110 to 230 million times the mass of our Sun. Supermassive black holes are believed to be common fixtures in the centers of galaxies, including our own Milky Way, and their presence profoundly shapes the evolution and dynamics of these cosmic structures. When matter, such as gas and stars, ventures too close to a supermassive black hole, it forms an accretion disk around it. This disk, which is rotating, heats up and emits intense radiation at various wavelengths that contribute to the brightness of the active galactic nucleus. Astronomers discover a brighter area near Andromeda's supermassive black hole, the result of unique interactions between the black hole and the. As we delve deeper into the mysteries of the cosmos, it becomes clear that the story of Andromeda is not just a tale of stars, gas, and dust but a window into the grand, ever-changing dynamics of the universe itself. One of the most fascinating aspects of this unfolding cosmic drama is the future merger between the Milky Way and Andromeda. While the distances between individual stars are so vast that direct collisions between stars are unlikely, the gravitational interactions between the two galaxies will reshape both dramatically. Currently, Andromeda and the Milky Way are hurtling toward each other at a staggering speed of around 110 kilometers per second. While that might sound alarming, the collision itself won't take place for another 4.5 billion years, giving Earth and its inhabitants ample time to witness the gradual dance of these two galactic giants. As the two galaxies draw closer, the gravitational forces between them will create tidal distortions, stretching and warping the shapes of both the Milky Way and Andromeda. Over time, these distortions will lead to the formation of long streams of stars and gas that will stretch out into intergalactic space. The interaction between the galaxies will likely ignite bursts of star formation, as clouds of gas within both galaxies collide and compress, creating new regions of star birth. These regions, often referred to as starburst regions, will be some of the most luminous and active areas within the merging galaxies, shining brightly with the light of thousands of newly formed stars. The collision will also trigger the formation of new star clusters, as gravity pulls together stars and gas into dense, compact regions. Interestingly, while the merger will lead to a dramatic reshaping of both galaxies, it won't be a single, sudden event. Instead, it will take place over the course of several billion years, as the two galaxies pass through each other multiple times, each pass creating new distortions and new interactions. Eventually, the galaxies will settle into a new, more stable configuration, likely forming a giant elliptical galaxy. This new galaxy will be much larger and more massive than either the Milky Way or Andromeda on their own, containing the combined mass of both galaxies. The supermassive black holes at the centers of the Milky Way and Andromeda will also play a crucial role in this merger. As the two galaxies merge, the black holes will gradually be drawn together by the gravitational forces at play. Eventually, the two black holes will merge into a single, even more massive black hole, which will dominate the core of the new galaxy. The energy released during this process, known as a black hole merger, will be immense, sending out ripples through space-time in the form of gravitational waves. Although the merger between the Milky Way and Andromeda is still billions of years away, scientists are already studying other galaxies in various stages of merging to better understand what will happen when our own galaxy undergoes this process. Observations of galaxies like the Antennae galaxies and the Mice galaxies, both of which are in the midst of mergers, provide valuable insights into the dynamics of galactic collisions. These galaxies exhibit many of the features that we expect to see during the Milky Way-Andromeda merger, including tidal tails, starburst regions, and the gradual coalescence of their central regions. Another aspect of Andromeda that continues to intrigue astronomers is the presence of its satellite galaxies. Andromeda is orbited by a number of smaller galaxies, including the well-known dwarf galaxies M32 and M110. These satellite galaxies, along with others, are gravitationally bound to Andromeda and are gradually being pulled closer to the larger galaxy. Over time, Andromeda's gravitational forces will likely lead to the gradual absorption of these smaller galaxies, a process known as galactic cannibalism. This process of galactic cannibalism is not unique to Andromeda. In fact, the Milky Way itself has a number of satellite galaxies, including the Large and Small Magellanic Clouds, that are gradually being pulled toward our galaxy. Some of these satellite galaxies will eventually be absorbed by the Milky Way, adding their stars and gas to our galaxy's overall mass. One of the reasons scientists are so interested in studying Andromeda's satellite galaxies is that they offer clues about the dark matter that surrounds galaxies. Dark matter, a mysterious and invisible form of matter that makes up the majority of the universe's mass, plays a crucial role in shaping the structure and evolution of galaxies. By studying the orbits and motions of Andromeda's satellite galaxies, scientists can learn more about the distribution of dark matter within the galaxy and how it influences the motions of its stars and other celestial objects. As our understanding of Andromeda deepens, it also provides valuable context for the study of other galaxies throughout the universe. By examining Andromeda, astronomers can draw parallels with other spiral galaxies, helping to refine our models of galaxy formation and evolution. The detailed observations of Andromeda made possible by advanced telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, serve as a benchmark for understanding galaxies across a wide range of distances and stages of evolution. Andromeda also holds a special place in the search for extraterrestrial life. As one of the closest galaxies to the Milky Way, it offers an intriguing target for future missions aimed at detecting signs of life beyond our own solar system. While Andromeda is far too distant for current space probes to explore, advances in technology may one day allow us to send robotic explorers to its star systems, potentially uncovering new forms of life or other phenomena that could reshape our understanding of the universe. The study of Andromeda is a reminder of just how interconnected and dynamic the universe is. The more we learn about this galaxy, the more we uncover about the forces that shape not just Andromeda, but galaxies across the cosmos. From the mysteries of dark matter to the dramatic spectacle of galaxy mergers, Andromeda continues to offer new insights and challenges to our understanding of the universe. As we continue to probe deeper into its secrets, Andromeda remains a symbol of the vast and awe-inspiring nature of the cosmos, an enduring reminder that we are but one small part of an ever-expanding and ever-evolving universe.